All right. Welcome to day 2 of digital learning. So, before we get started here, you're going to have to find yourself the note packet from part 6 that we did the first half of together, as well as some sort of piece of paper or scratch space on a worksheet or something where you can do a warm-up. So I'm going to put a warm-up on the screen for you right now. So you're going to pause the video. This problem says students investigating the packaging of potato chips purchased 6 bags of Lay's Ruffles marked with a net weight of 28.3 grams. They carefully weighed the contents of each bag, recording the following weights in grams. And then there's 5 questions for you to answer about it. So I'm going to have you pause, find some scratch paper, and do this warm up to your best of ability, and then we'll go over the answers. Okay. Let's quick take a look at what you did. So we're going to start with checking, does this situation, do these data satisfy the assumptions needed to satisfy for inference procedures? So first things first is you're going to have to assume that those 6 bags of Lay's potato chips are a random sample of all of their potato chips put together. And so that's kind of an assumption that you have to make, that when you pick 6 bags off the shelf, that they would be a random sample, which I think is a fair assumption. Then, second one is that 6 is less than 10% of all Lay's potato chips bags, which seems totally fair. After that, hopefully you made a histogram of what this looks like, and when I zoomed 9 to my histogram, with only 6 things, it looked like this. Which is roughly symmetric and definitely only has one mode. And so we're going to say yes, that those 3 conditions are met for inference. Part B says to find the mean and the standard deviation. So you press stat calc one variable stats, and your mean and standard deviation are 28.78 for the sample mean and 0.402 for that sample standard deviation. Part C says to take those numbers and create a 95% confidence interval. I actually did this with my calculator, so I pressed stat, went over to tests, did a t interval for these data points. And the interval in my calculator came out to be 28.361 to 29.205 grams that we were seeing between those bags. Then part D said to explain what that interval means. So using our little stem of describing, that interval means that we are 95% confident that the mean weight of bags of Lay's potato chips are between 28.361 and 29.205 grams. And last, it says to comment on the company's stated net weight of 28.3 that was printed on the bag. 28.3 is not in that interval, which means that it's not reasonable, and I have evidence that the company is filling their bags to a higher weight. So that number that they're posting on their bag is like conservative. They're generally trying to fill it to more than that to make sure that they are meeting what they're saying that they're meeting. All right, so that is sort of our wrap up here for the week on one sample mean. And what we're going to do is we're going to transition over to 2 sample mean and then do some practice with that throughout the rest of the week. On Friday, your quiz will have both 1 and 2 sample means on it. And so we'll make sure that you get enough practice on this 2 sample mean in the next couple of days here. But find your notes, open them up to the chapter 23 section, and we're going to start at the top when you're ready. So the notes here say, when and how do we compare 2 means with inference? And the top is just kind of describing the need for this method of inference, and says comparative studies are more convincing than single sample investigations. So 1 sample inference is not as common as comparative 2 sample inference. You're going to see this happen a lot more often. And what 2 sample inference looks like in those comparative studies, we might be comparing either 2 populations together or against each other, or we might be comparing 2 different treatments against one another. In either case, you need to choose your samples randomly and independently, or apply your treatments randomly and independently. So when you have 2 different populations, it's tempting to want to do what we call match pairs, and we will talk about that. If you remember when we were talking about 2 proportion tests, we talked about the idea of doing like husbands and wives or twins, and that's kind of the idea of match pairs, and we'll get into that next week. But for now, because those match pairs are not chosen independently, we don't use 2 sample inference for those match pairs designs. We'll talk about what that looks like next week. Really, again, this process is going to feel like a hybrid between what you know about one sample T inference and what you know about two proportion Z inference. And so we're going to just kind of skim over just the new bits and then use an example problem to kind of learn it and teach it. So the new bits are the assumptions. You're going to have 3, and again, they feel similar. There's a random, there's an independence, and there's a is your sample large enough condition, and those are the 3 that we're going to talk about. Here's specifically what they look like. So, number 1, both of your samples should be randomly chosen or representative of the populations that they're supposed to represent. Number 2, your 2 samples should be independent of each other, meaning that knowing something about one of your 2 samples shouldn't tell you anything about the other. And then 3, both of your populations should be relatively normal in the same sort of way that you check that one population is relatively normal using a histogram. And that will tell you that you have samples that are large enough. So those 3 conditions are going to feel similar to the 3 conditions you already know. The only difference is you have to, obviously do each one twice and make sure that they're true for 2 different samples instead of just 1. Once you have that, your test statistic is going to look similar to what you already know. You're going to take your 2 means and subtract them. Your null mean is typically 0, that because we're assuming that the 2 populations have the same mean, so that difference would be 0. And then down at the bottom, you're taking that standard error formula, that S over the square root of n, and again, thinking back to the part about combining random variables, when you take a standard deviation to combine them by subtraction, you have to square them first to go to the variance. And so what that does is that makes the S on top squared, and it cancels out that square root that used to be with the n on the bottom. And so those are both your old standard deviation formulas that we were using yesterday, but they're both squared to go to the variance. Then, regardless of the fact that we're subtracting 2 population means, you're adding the 2 variances together, and that's where that plus comes from in the middle, and then square rooting to go back from variance to standard deviation. The other thing is, again, we still have degrees of freedom because we're talking about means. The degrees of freedom formula is in your textbook in chapter 23. You're welcome to go look at it since you're sitting at home and you probably have it nearby somewhere. But it's a super complicated formula. We're just going to find degrees of freedom from your calculator, and I'll kind of walk you through how that goes a little later. And then the interval formula, again, starts with taking your 2 means and subtracting them, and then adding and subtracting a t-critical for whatever your degrees of freedom is, and then multiplying that by your standard error, as we already talked through on the bottom of your test statistic formula. And so those are the formulas that you're going to use. They'll go on your green grid sheet. Probably, I think it's tomorrow or Thursday that we add those to there. And then you'll have that to use on all of your quizzes and tests and stuff. Okay, so what we're going to do is we're going to work a problem here together. So the problem down here says, and I kind of underlined as I was reading through it, but it goes like this. Resting pulse rates for a random sample of 26 smokers had a mean of 80 beats per minute and a standard deviation of 5 beats per minute. Among 32 randomly chosen non-smokers, the mean and standard deviation were 74 and 6. Both sets of data were roughly symmetric and had no outliers. Is there evidence of a difference in mean pulse rates between smokers and non-smokers? And so I underlined all the things that I thought would be important to us. In purple is all of the first sample of smokers. In red is all of the second sample of non-smokers. And then in gray, I underlined things that are going to be helpful for writing our hypotheses and doing our conditions and assumptions. So what we're going to do is we are going to write out the phantoms procedure. And if you'd like to give this a shot beforehand, you're welcome to. Otherwise, you'll have a chance to practice one on your own in a minute. But we're going to start with the P step. So on my P step, I'm going to define 2 means, 2 parameters, and I'm going to use S and N to represent smokers and non-smokers. That just kind of helps me stay organized. And so I'm going to say that mu S is the mean pulse rate of smokers, and mu N is the mean pulse rate of non-smokers. And we're going to be comparing the difference between those two, same as what we did with 2 proportion, where we were subtracting the 2 sample proportions. We're going to be doing that as well to make some sort of inference about, are they different, are they the same, is one larger than the other, things like that. So we're going to write our hypotheses, and your null hypothesis is always going to look like this, that your 2 means are equal, and that's sort of essentially the same thing as if I said mean of the smokers minus the mean of the non-smokers equals 0. And that's where that 0 came from in that test statistic formula that we just talked about before. Again, your alternative hypothesis has 3 choices. It can be a greater than, a less than, or a not equal to. And in this case, I underlined the question that it was asking me was, is there evidence of a difference? It didn't specify that it was looking at were smokers higher than non-smokers or lower than. It just said, is there evidence of a difference? So when I write my alternative hypothesis here, you're going to see me do it with just a not equal to sign. And you could also write that as mu s minus mu n is less than or is not equal to 0. Okay, you could also write it as a difference as well. So mathematically, those are equivalent. All right, we're going to do our assumptions and conditions, all of your favorite parts. And that's going to look like this. So both of my samples are random, and they gave me that in the problem. It said a random sample of 26 smokers and 32 randomly chosen non-smokers. Then it says that I have to figure out, are the pulse rates of the two groups independent? So if I know that the mean pulse rate of the non-smokers is 80, that doesn't really tell me, or is 74, that doesn't really tell me anything about the mean pulse rate of the smokers. And so knowing about one group's pulse rate doesn't tell me anything about the other, which makes your two groups independent of each other, which is good. We need to check that condition as well. And then lastly, they gave us in the problem, and I underlined it in gray, that both groups or both sets of data are roughly symmetric and have no outliers. And so they were telling us, basically we didn't have to make the histograms here because they told us already that that was true. And so your 26 and your 32 are large enough. All right, so your assumptions and conditions are met, meaning that you are able to do a 2-sample t-test. Now, we do not yet know what the degrees of freedom is, so I will come back and enter that in just a minute. What I do want to do right now, though, is I want to organize all the information that we have, the x bars, the standard deviations, and the ends, into one little table. So I'm just going to take every number that was given to me in the problem, sort of organize that into one space. And so here, my mean of the smokers was 80, the standard deviation of the smokers was 5, with a sample size of 26. My mean of my non-smokers was 74, with a standard deviation of 6 and a sample size of 32. Kind of organize all that information together. I want you to grab a calculator or your simulator of a calculator, whatever you're using. You're going to press the stat button. You're going to go over to tests, and you're going to do number 4, which is a 2-sample t-test. You've got 2 options here. You've got data or stats. Now, usually we have 2 sets of data. This time I've got statistics. And so for those statistics, you're going to go highlight that stats option, and you're going to type all these numbers in. So for my x1, I'm going to do 80, and then sx1, I'm going to do 5, and then n1, I'm going to do 26. And then I'm going to enter my numbers for my non-smokers underneath there. So 74, 6, and 32. And then the last thing you need to do is the second to last thing you're going to do is you're going to choose what your alternative hypothesis is. And this time we're doing a not equal to. So you're going to click that first option that says mu1 is not equal to mu2. And here it's going to ask you if you want it pooled or not. We are not going to pool for 2-sample t-tests. Remember I said we're just going to pool when we're doing 2 proportion z-tests. So you're going to go ahead and leave that clicked no all the time and then hit calculate. All right, at this point, what I want you to find is your test statistic, your p-value, and your degrees of freedom. And you're going to see me kind of write out that formula for the test statistic here, following the formula that's just above here on your notes. Hopefully you're writing small. I know I kind of gave you a small space to do this here. I'm not actually going to use that formula to do any of my calculations. My calculator tells me that test statistic comes out to be 4.15, but if you did it all in your calculator, you'd get the same thing, with a p-value of 1.12 e negative 4, meaning move that decimal place 4 to the left. And then degrees of freedom says 55.9. I'm just going to go ahead and call that 56. So you're going to see me enter in all of those numbers in red. So 4.15 for my test statistic, 56 for my degrees of freedom, and then I went ahead and moved that decimal place over, so 0.000113. And hopefully that all matches what you got in your calculator, and if not, we'll talk about it during office hours tomorrow. Or feel free to send me an email, of course, and I'll try to help you figure it out. Then you're going to go ahead and write your conclusion. I bet you can all do that from this point. So you're looking at your p-value, you're deciding is it large or small, and then you're making your decision. So in this case, my p-value is small, and so that leads me to believe that the null hypothesis that I've been operating under the assumption is true is not actually true, and so I reject the null hypothesis. And then I need to put that decision into context. So I'm going to say, okay, so I reject the null hypothesis, meaning I have evidence that there's a difference between those mean pulse rates between smokers and non-smokers. So I have evidence of a difference in pulse rates between those two groups. Okay? Now, if you look back at the problem, you're going to notice the second thing it asks you is how big of a difference. Do you notice it says how big after it asks is there evidence of a difference? And so if you flip your notes over, we're going to create a 95% confidence interval for that same situation. And remember, my degrees of freedom was 56. And so I'm going to create that confidence interval. Now, I'm going to make my interval, and it goes like this. It starts with 80 minus 74. That is the difference between my two means. So my best guess is the difference is about 6 beats per minute. But I'm going to make an interval based on that. And so I need to add and subtract, and I need to find a T critical for 95% confidence and 56 degrees of freedom. So I'm going to have you pause and go to your table, your book, or your calculator and find that T-score. Okay? And then that T-score that you should have found should have been 2, and then we're going to multiply that T critical value by your standard error formula. So 5 squared over 26 plus 6 squared over 32. From here, you can build your interval using the math that we just laid out, or you can press stat, go over to the test menu, and do a 2-sample T interval to get that interval. And what you should end up with is an interval of 3.1064 to 8.8937, and then you're going to write your conclusion. You're 95% confident. Notice that those are both positive, and the interval that we made was smokers minus non-smokers. And so since both of those endpoints are positive, that means I have evidence that, well, I'm confident that smokers have pulse rates that are between 3.1063 and 8.8937 beats per minute higher than their non-smoking counterparts. And again, because 0 is not in that interval, that backs up the results that I just got. I have evidence of a difference, because if I didn't have evidence of a difference, 0 would be in my interval somewhere, okay? Hopefully that's all helpful. What you're going to do is down at the bottom, I'm going to try to tell you what to do here. Okay, so down at the bottom, you're going to see a problem here that says there are saturated fat content grams for several pizzas sold by 2 national chains, brand D and brand PJ. I bet you can't guess what 2 brands those stand for. And then the question says, is there a difference in saturated fat content between the 2 brands? So you're going to put together a hypothesis test for that first. And then if you end up with the results, because your p-value is low, reject the null. If you're deciding to reject the null and you have evidence of a difference in that fat content, then if that is the case, I want you to do an interval like we just did for the pulse rates to tell me, if so, what is that difference. So here's what I want you to do. I want you to pause. The answer is all going to show up at one time, and I'm not going to talk super in-depth about it today because you're still going to have time to practice. But I do want you to try this problem as if you were sitting in the classroom and I was walking around and helping you. And when you're done with the whole thing, go ahead and restart this video, and I'll kind of touch through some pieces of the problem, but I'm not going to work it through step by step like I did on here. You're just going to use the end of this video to check your answer. So pause and give it a try. Okay, so let's check this problem. You're going to see on here, I took a picture of my work. It's a little blurry. Do the best you can to check the important parts, and I'll try to point those out to you. So number 1, all of my statistics from the 1 variable stats for my 2 samples are over here on the top. So first thing I did is I typed all of Domino's into L1 and all of Papa John's into L2, or D and PJ, and that I did 1 variable stats on both of those. Okay, and that's the numbers that I got. So the first one I did was one variable stats, and then I just hit enter, and that's how I got my L1. And then I did one variable stats, and I actually physically typed in L2, and that's how I got those numbers. Check your hypotheses to make sure you just did a not equal to alternative hypothesis. Go ahead and check your assumptions. I had to make some assumptions. Number one, you're going to see I said assume that these pizzas are representative of the brands. And then if you look at the PJ histogram, it's not really very symmetric. And so you're going to see I underlined the words proceed with caution. I still want to do the test, but you're going to see right there that I said be careful with these results. Okay. Degrees of freedom came out to be 33. My test statistic was 4.82. I circled that. And my p-value was insanely low, 0.0000315. Hopefully all that matched what you got. If not, try typing it all into your calculator again and give it another whirl. Otherwise, send me an email. And then your conclusion, because that p-value is low, you reject the null. There is evidence of a difference in mean fat content. Which means then you had to do part 2, which is said, if so, what is that difference? And so you built that confidence interval. Your t-critical for 33 degrees of freedom down here, you're going to see I wrote is about 2.037. And then built the interval from there from 2.7266 to 6.7067, and then write that conclusion. Okay? I believe that is all I have for you to do today. If you did these notes, no need to show me anything. We'll do practice the next couple days. So just a reminder, come back here tomorrow, and it's just going to be a practice day. I'm going to make a Google form for you so you can kind of do some practice and sort of self-check as well. And then Thursday is going to be an opportunity for you to work on your homework packet and get some help on that so that I'm not totally leaving you with a ton of hours of stuff to do besides all the stuff that you're already doing at home. I want to give you a day to work on that homework packet, but make sure that you're using that. It is great practice for you. All right. Thank you guys for watching. Hope you're still doing well. Reach out to me if you need anything.